Hi everyone, welcome back to ANSYS tutorials by the Knowledge Alpha. In this video, we will learn how to perform stress analysis in a plate with a hole at the center by using ANSYS structural. If you have not watched our previous videos, please do watch them. Let's head into the problem now. Here we have a steel plate of these dimensions 0.1 meter by 0.1 meters by 0.01 meters, and we have a hole at the center of this plate of 0.025 meters. One end of this plate is fixed, so this plate cannot move in any direction. Along this side will not move in any direction, and on the other side we have a uniform load of the magnitude 10,000 Newton per meter square acting along a span of 0.05 meters. The properties of this material are given here. So it's a kind of steel, and the Young's modulus is 210 gigapascals and the Poisson's ratio is 0.32. Whenever we have a load like this, so the load is acting along this direction, let's call it X. So when the load is acting along this direction, there will be tensile stresses developed in this plate, and the load is pulling the hole towards this direction. Because of that, there will be weaker points along here and here. That means the stress will be maximum in these 2 points, and there is a high chance that the material will fail along these 2 points. Let us see how the stress varies in this plate when the load is acting on this by using ANSYS workbench. Also, we have to find out the maximum von Mises stress, total deformation, directional deformation, and maximum principal strain by using ANSYS. Let us see how to do that. And I'm going to static structural. So the first step would be to define the material properties. So I'm going to engineering data. Okay, I'm adding our material here. So let's name it as steel. And let's define the properties of this steel here. So I'm defining the Young's modulus and Poisson's ratio. Young's modulus is 210 gigapascals, so let's define that. And the Poisson's ratio is 0.32. Okay, we have defined the material properties. Now switch back to project and start modeling. I'm selecting design modeler now. I'm going to XY plane. So I'm zooming in so that you can see that the scale will be matching our dimensions. So I'm just going to sketching. So this is the rectangle, and let me give the dimensions. So this is 0.1 and this is 0.1 as well. You click on generate, and there is a hole at the center of the plate, so I'm drawing a circle. This circle will represent the hole. Let me give the dimensions. So this is 0.05 meters and this is 0.05 as well. Okay, so we have the 2D model of our plate. Let's extrude it and form a 3D model. So click on extrude and let's change the depth to 0.01 meters. Just click generate. So we have a steel plate ready. But if you see the question, you can see that one of the ends has fixed support, so it's completely fixed, and the other end there is a uniform load only across 0.5 meter span. So let me create a new plane with on this face. So let's select this face and create new plane. So this face is already selected, so just click on generate. This will generate a new plane, you can see that, and just start sketching on this. So I'm just selecting line, and another line as well. Okay, now let's give the dimensions to these lines. So the first one would be 0.025, the second one would be 0.075. Perfect. Now let's split this face by using these two edges. So go to tools and select this face split. So the target face is this one, so let's select the target face and select the two edges as well. So just select edges. Okay, perfect. Now click generate. I'm selecting faces again to see if the split has been made, and you can see that the face is divided into three parts now. There will be load acting only on this plane. So we are done with the modeling now. So let's switch to meshing. So I'm opening the meshing. So we have a plate with a hole. So the first step would be to assign the material. I'm just going to geometry, and you can see that the material assignment is structural steel. We have to change it to the steel we have defined. So you can see the steel which we have defined here. So click on steel, and now we can generate the mesh. Just right click on it and click generate mesh. We can see that the mesh generated here is not that good, and we will not get accurate results with this mesh. So let's refine the mesh now. So if you select the mesh, I'm changing the element size to 0.002. So I'm just changing it to 0.002. Click generate again. Okay, now the mesh looks better. However, there will be more stresses along this circular hole, so that's why we have to refine the mesh there. So I'm just going to mesh, and I'm setting a sizing. So I'm selecting the edges, so this edge and the other edge. Just want to select 0.0001, so it's very refined mesh. So I'm going to mesh again and just generating the mesh again. We have our mesh ready here. You can see our mesh, it's very refined near the edges. Okay, this is good. Now let's go to the static structural and start defining our load and also the fixed support. So we have a fixed support on this side, so let's start with that. Insert fixed support. So I'm selecting this face, apply. Now let's select pressure, and the pressure is only along the center. You can see that the face has been split, so only along this. Apply, and the magnitude of the pressure is 10,000 Newton per meter square or pascals. So I have defined it. Now let's start with the solution. Now we are solving it for total deformation, directional deformation, and let's go with maximum principal strain and 1 MISE stress. Now let's click on solve. Our solution is ready now. So just see the total deformation. You can see that the total deformation is more along the loading zone. So this kind of gives us an idea that the solution might be correct. So you can see that the hole has deformed into an oval shape, and the maximum deformation is 4.078 into 10 power minus 9 meters. And now if you see the maximum elastic strain, you can see that the strain is maximum along and near the circle, and it's also near the loading zone, so it kind of makes sense. Now go to equivalent stress. You can see that there are red zones, red zone exactly near the center here and also here. So these two are the weaker points, and you can see that the maximum equivalent stress is 22992 pascals. So we can also see the animation of the stress or deformation or strain or anything. Just go to animation tab and click on play, and you can see how the stress is varying with respect to time. See, the circle is getting changed to oval shape, and that's because it is deforming, and also the stresses, see, it's increasing. That's all for this tutorial, guys. Thanks for watching. Please don't forget to watch other videos and also like, share and subscribe. Thank you so much.